We've done pre-processing with CONN of resting state functional MRI data, and now we're going to keep moving through the processing, and these next steps won't take that long to do. So the first thing we will do is open up the on-demand service, ood.rc.ufl.edu. And again, I'm already on a VPN since I'm currently off campus. If you're on campus, then you could just load it right up. Off campus, you need the VPN. So we're going to start a console session. I'm giving this one core, 5 gigabytes of RAM, let it run for 12 hours. Again, you can play around with those numbers, but that should work well for this. This just takes 5-10 seconds to start. So then we can launch the console. First thing I like to do is navigate to the location of the data. So in the console window, cd/ufrc/clp7934/share homework data, and then I go into my directory and then into CONN. And so this has all of the data. And once we're there, we can make CONN available. So module load GUI 2.0.0 module load CONN 18A. So when we load CONN this way, this makes both MATLAB and SPM available. SPM is the software that CONN uses to do all the processing of the data. And SPM is one of the most popular functional tools for MRI data. And so we load like this, and that is all already set up. So there are two ways to launch. You can do MATLAB or CONN, and this will load CONN right from this command line in one command. But if you happen to have MATLAB already running, or you have MATLAB on your personal computer and you've downloaded CONN and SPM, this is how you would launch it. You would open MATLAB, and this is going to take a little bit of time to load over here on Hypergator. So what I'm going to do is open a new window and show you SPM. So we're going to search for SPM fMRI and can get right to the download for SPM. And so you would select the newest version of SPM or an older version if there's a reason to do that. They do have a standalone where you don't need MATLAB, but you fill this out, you download it, and you would, with MATLAB installed, you would tell MATLAB where your SPM is housed, where that directory is. So that's SPM. CONN is conntoolbox.org. And this you can download the software, but they have a new version of it. So the newest version of CONN is newer than what's on Hypergator. And there are some reasons to use it. They've updated some of the processing in it. So this is CONN version 19C. And so it could be downloaded and you can run it. They do have a standalone version as well. So here's your files for standalone installation on a Mac, files for standalone installation on Windows. And so they're calling that's CONN 18B. So the newest version, this 19C, they don't quite have all together as a standalone version. But again, that's what you would run if you don't have MATLAB. There are ways to run it, and it just will use the MATLAB runtime. So again, you don't have to have MATLAB, which can be pretty pricey if you don't get it through university. But if you have MATLAB, then you can use the other versions of SPM and CONN. So here's MATLAB has been open now, and if you wanted to use a newer version of CONN, we can here on Hypergator. You would just have to have it loaded to a location on Hypergator that you have access to, and then you would set the path to it. And so it would be somewhere like your UFRC and then your folder, the class folder somewhere, but I don't recommend that for this project and for our class. So if you have MATLAB running, you just type CONN and press enter, return. Again, the faster way is just to do that right from the command line from the console, MATLAB-R CONN, and that will speed up this process so you don't have to do over 2 commands. So CONN will just take a little bit of time to run, depending on how bogged down the VPN is or Hypergator. For the GUI access, it can take a little bit longer amount of time. This is being reasonably quick. So we're assuming now that you don't have a running console session, that you did the pre-processing and your console session has ended. And so you need to open up the project. So what I like to do, as I had shown already, is navigate to the location of the files, because then I just click open and we can open up the project. Now this top folder is the subdirectory that will have the results of the processing, and that is named whatever you named the project. So in my case, I named it CONN TK class, and if you had a different name, if it was just TKA class or jumping rabbits, again, whatever the name of your project is, that's what you'd need to search for. So we're going to search for the matlab.mat file, and that's the project file that kind of explains where the data are and how it's organized and all of that. So I search, and then I highlight it and we click open. So this will load the project data. It's going to check the data files to see if they've been processed more or if they've been moved. And so we're seeing everything that we have here. So what we've done already is the pre-processing, so we don't need to do that again. Now we're going to click done. This will save changes to the setup step and run everything else, the processing that needs to run before we get to denoising. So I can click on done, and if you've already run some of the data, let's say you were adding more data to your data set, you could change this to do not overwrite, skip already processed subjects or seeds. Or if you were adding a new atlas, new region of interest, let's say you wanted to look at a part of the brain called the nucleus basalis of Meinert. That's an area that produces a lot of acetylcholine for the brain. Let's say you wanted to look at that area, you get a region of interest as a nifty file, you could load that in and you'd have to do some pre-processing with that. So what you can do is you can do not overwrite, skip already processed subjects and seeds, but if you haven't already done this step, then it's just overwrite, proceed for all subject seeds. So right now I recommend don't change that top setting at all. And I already have done this next step, but I will overwrite. So I will run it again, and that takes a little bit more time than skipping. And then we're going to change this to run on a Slurm computer cluster. So I'm going to start, and we're going to give it the number of parallel jobs. For this purpose, I'm doing 6. And I'm going to highlight these jobs and click stop. You might see a notification about a job that's already running. Do you want to add this to the queue? If that's the case, then you can click yes, that's okay. Because what happens when you do the pre-processing, and if you split it up like this, where we're doing parallel jobs, then once the processing is done, CONN has to put the jobs back together. So it splits up the brains into 6 different jobs. So in here we have 10 brains. And so most will have 1 brain, but some of the jobs will have 2 brains that they're doing. and or parts of jobs, and you have to put that all back together. Or CONN will do that automatically, but it's possible that you can get that waiting to do that when you're here doing the next step. So now what we're going to do is go and edit these jobs just to give them a little bit more time. So I can go back over to the window, my interactive sessions in this case, and I'm going to open up the File Explorer, go into Share, Homework Data, My Folder, CONN, and then there is a .qlog folder. So I have multiple files in here. You might have one, you might have two. Hopefully you don't have more than two, but if you have one, then you'd go in that folder. If you have two, then you would go into the newest one. So over here I can see modified date of a number that were modified yesterday and one that's today. So I'm going to go in there and I can see these 6 jobs that are stopped. So I'm going to go and edit the shell script, and you may or may not have a space here on line 2. If you don't, that's fine. You just add in sbatch mem, and in this case I'm going to give them 4 gigabytes of RAM for each job. Well, let's say 3. Shouldn't need that much RAM, but we'll be safe. And then time, I'm going to give this 2 hours, so 020000, and that should be plenty of time. This should only take about 10 minutes per job. It could be half an hour, it could be an hour, but we'll give this 2 hours to run. If you happen to run out of time, then you'd need to go back and edit this and or delete some files and add more time to this. We won't go into that, so hopefully there'll be enough. If you're worried about running out of time, you can give it more time, and that's okay to do. So I'm going to copy this and click save, because now I can go and edit all of these scripts to add in the time and the RAM. Okay, so last one, and then we will be good to run them. So those are all edited now. And so then I just go back over to the window and click restart. And this will submit the jobs, they get in the queue to start processing, and then as we can see, they're starting to run. If you're interested, we can go here and click on it and see the log, and it'll show what it's doing. And so importing functional data, you have to refresh this to refresh the log, and you can look at the different nodes. So these are the different jobs that are running. And again, if you happen to see if there was an error, you could look at each job and kind of see where it is or where it got stuck. So now it's importing region of interest data. So it's making progress. So this may be pretty fast of a processing. This may be running a little faster for me because it's done some of the processing before, and so all of the setup has already been done. But it shouldn't take more than about 30 minutes, maybe an hour per job. In my case, it might be a little bit faster, but I'm going to stop this video, and then once this is done, we'll do the next video in the series.